This is Christine Love. I'm coming to you today to talk briefly about the Harbour Cay condominium failure that happened in 1981. So we'll start with a quick roadmap of this presentation. I am going to talk about the pros and the cons of the structural system analysis. We'll talk about the engineering concept, which is punching shear. I'll talk briefly about the story of this failure, basically the concerns of the GCs and then the failure itself, and then conclude with the aftermath, which is basically the consequences and effects such as the lessons learned and the laws changed because of this failure. So the structural system of this project was a flat plate reinforced concrete building. So what is that? It's basically a type of structural system containing slabs with uniform thickness supported directly on columns without the use of beams. So there's no bracing. So here's a picture that you're probably familiar with. You've probably seen it in parking garages. Here's another one of a high-rise. So the advantages. Basically, the flat plate reinforced concrete structures have simple formwork. So this saves in costs and also in time. There are no beams, and it's minimum structural depth, which reduces the floor-to-floor height. Disadvantages. This structural system can only span medium distances because there is no bracing, limited lateral load capacity. It may need reinforcement at the columns for shear, and we'll talk about that briefly. Long-term deflection may be a controlling factor in design. It may not be suitable for heavy loads because of punching shear, and we'll go into depth about what punching shear is exactly. So the concept. Punching shear, what is it? If you look on the right hand side, you can see a column with a piece of slab above it, and you can see where it's cut off, and basically it's 45 degrees. So that may trigger something in your brain, and I'll talk about it in a minute. So punching. As the slab transfers its load downward to the column is pushing upward. If the slab isn't strong enough, this can cause the column to breach the slab. If the column breaches the slab, it's basically sliding against it, which is shearing off. The slab slides down the column as the column pushes through the slab. This failure happens at 45-degree angles, which is also indicative of shear failures. So if you guessed that, I'm happy for you. You know your concepts. And here's basically a simple diagram. As the forces are being applied downward on the slab, the column is pushing upward, and you can see where it breaks off at 45 degrees. So a couple ways that you can reinforce flat plate concrete slabs is by column capitals. Column capitals increase the column size where the column meets the slab above. So it's basically that trapezoidal shape at the top of the column. Another way that you can reinforce this sort of structure is by a drop panel. So drop panels increase the slab depth above the column where the column meets the slab. So that's the rectangle shape above the column. So the story. This failure happened on the 27th of March in 1981 at 3 p.m. in the afternoon. The general contractors had voiced concerns to the architects and engineers prior to the failure concerning cracks located beside the column locations. The architect was supposed to be looking into this failure or this issue, but he didn't get to it before the failure happened, and then the engineers had responded that the cracks were fine, which is really bizarre. As the story unfolds, basically this was a 5-story flat plate reinforced concrete structure. Each of the 5 floors had been poured in 2 section segments. The roof was supposed to be completed in one continuous pour. When the failure occurred, there was 50 to 60 workers on site. 12 of those workers were on the roof. The punching shear started with a column on the 5th floor. Once the 5th floor failed, the structure collapsed like a deck of cards. So here's some quick pictures of what happened and then the aftermath. Basically, there were 11 deaths, unfortunately. There's 23 workers injured, and then the architect ended up having his license suspended for 10 years. Both of the engineers gave up their license indefinitely, and then the GC lost his license as well. This failure created the threshold law, which was created and added to the Florida statutes, and we'll talk about what threshold law is. So basically, a threshold building is any building that's greater than 3 stories or 50 feet in height, or if it has a assembly occupancy classification and it exceeds 5,000 square feet in area and an occupant content of greater than 500 persons. So if your building meets any of those criteria, then you have to have a special inspection completed by a threshold inspector. So who is a threshold inspector? A threshold inspector could be a structural engineer, an architect, or another professional engineer who is licensed in the state of Florida to perform threshold or other special inspections. So the takeaway, in conclusion, basically safety first. So you need to be familiar with your structural design so that you know what to look for failure-wise. And then you need to also educate the people on site. So most job sites have foreman meetings every morning. You could quickly go over that. And then when people come to you with structural concerns, you need to be action oriented. So contact your project engineer, threshold inspector, or architect immediately. And then you need to document any communication between yourself and them. So basically you want to get it in writing. So with that, that concludes my presentation. I wish you all the most success with your construction careers, and I hope to see you out on the job site. Thank you.